Quantum computing breakthroughs, the future of supercomputing. Imagine a computer so powerful it can solve problems that today's most advanced supercomputers would take thousands of years to crack. But how does it work, and what real-world applications will it impact? Let's dive in. What is quantum computing? Traditional computers use bits, which represent data as zeros and ones. Quantum computers use qubits, which can be 0 and 1 at the same time, thanks to a phenomenon called superposition. Another key principle is entanglement, where qubits become linked, allowing information to be processed exponentially faster than classical computers. How is quantum computing different? A classical computer processes one possible outcome at a time. A quantum computer can evaluate multiple possibilities simultaneously, making it dramatically more powerful for complex calculations. This makes quantum computing perfect for solving problems that traditional systems struggle with, such as simulations, optimizations, and cryptography. Key quantum computing breakthroughs. Tech giants like Google, IBM, and Microsoft are racing toward practical quantum computing. In 2019, Google's Sycamore quantum processor achieved quantum supremacy, solving a problem in 200 seconds that would take a supercomputer 10,000 years. More recently, researchers have developed error-correcting qubits, bringing us closer to practical, large-scale quantum computers. Real-world applications of quantum computing. Drug discovery and medical research. Pharmaceutical companies spend billions on drug development, but quantum computers can speed up the process. They can simulate molecules at the atomic level, leading to faster drug discovery, personalized medicine, and new treatments for diseases like cancer and Alzheimer's. Companies like Pfizer and Merck are already using quantum simulations for research. Cybersecurity and cryptography. Today's encryption relies on complex mathematical problems that classical computers take years to break. Quantum computers can crack traditional encryption in minutes, posing a major security threat. However, they also enable quantum cryptography, which is unbreakable, ensuring secure data transmission for banking, government, and communication networks. Climate modeling and weather forecasting. Weather prediction and climate modeling require analyzing massive amounts of data. Quantum computing can improve hurricane predictions, climate change simulations, and natural disaster responses, making forecasts faster and more accurate. Optimizing logistics and supply chains. Quantum computers can analyze millions of possible routes simultaneously, optimizing transportation, logistics, and deliveries. Companies like DHL and FedEx are investing in quantum-powered logistics to reduce fuel costs and improve efficiency. Artificial intelligence and machine learning. AI relies on large datasets and complex computations. Quantum-enhanced AI could improve speech recognition, medical diagnostics, and even self-driving cars by processing data faster and more efficiently. Challenges in the future of quantum computing. Hardware limitations. Quantum computers are extremely fragile and require near-zero temperatures to function. Error correction. Maintaining stable qubits without interference is one of the biggest challenges. Cost and accessibility. Quantum technology is expensive, but companies are working on making it more accessible via cloud-based quantum computing. Experts predict that within the next 5–10 years, quantum computers will transition from research labs to real-world applications. The quantum revolution is coming, and when it does, it will redefine the limits of computing power. What are your thoughts on quantum computing? Do you think it will change the world? Like, subscribe.